Thank you, Calvin. So today we're going to talk about a topic that's not very discussed usually, which is securing KubeRay and running multi-tenancy within a KubeRay clusters. So if you're already using KubeRay, and this is an actual demo here for executing a KubeRay cluster on Kubernetes, and this is how long it takes. It takes roughly 12 seconds. I know it's not very readable, but you can see on the right-hand side, you will have a bunch of containers that are created, started, and it all happens within 10, 12 seconds. You would have a Ray cluster that's ready to support and handle workloads. And if you're wondering how this is happening under the hood, this is using the Ray operator, a KubeRay operator, which is just a piece of software that's used to manage other pieces of software. So KubeRay manages the life cycle of a Ray cluster. It creates the head node, the worker nodes, it creates a service between them, it injects a proper service name into the worker nodes to find the head node, and so on. So it does all this goodness for you. And it's very simple in order to create a new cluster. Now the question is, if you're creating now multiple Ray clusters, and if those Ray clusters are serving multiple tenants, then how do you start reasoning about securing those Ray clusters? Now, when talking about multi-tenancy, there's always the discussion that's going to come about whether this is a friendly or hostile multi-tenancy. Now, friendly means it could be in the same company, it's different departments, different organizations, so you're not worried that they will attack you. When you're talking about hostile multi-tenancy, this is, for example, if you're a cloud provider and you don't know who your tenants are, anyone can be a tenant, and you might have hostile multi-tenancy there. The second question to ask is whether I'm serving my code or whether I'm serving a customer code. So if, for example, you're serving inference, that's your code, that's your model. You just take an input and return an output. You're not really executing customer code. But if you're executing customer code and it's hostile multi-tenancy, now you need to have a real hard isolation between the different tenants. So this circles here is just to show the level of complexity. Obviously, if it's friendly and you're serving your code, it's much more simple than if it's hostile and you're serving customer code there. So you can think about it as at the lowest level, if you have friendly multi-tenancy, you can get away with just defining certain boundaries. So the boundaries are clear, but the isolation is not that strong. You can even have stronger boundaries, but it's still considered friendly multi-tenancy there. Now, once you get to hostile multi-tenancy, this is where you need to set up real barriers in place and make sure that you have no breach to your walls. Today, we're going to discuss more of all three different levels because it's incremental, but we're working gradually towards the hostile multi-tenancy there. So when thinking about security, where is a good place to start? And I think the good place to start is go as low as possible in the stack. So if you start at the process level, process is just an executing program. It takes input as data, produces output, which is information. Obviously, you can pipe multiple processes together. One process's output, which is information, can become data for another process. But if you're thinking about it from an operating system point of view, a process is using computing resources. It's going to use CPU, memory, disk, networking, and so on. And it's going to have privileges. So it's going to make system calls. It's going to access the file system, the network, and so on. And your job is really to know how to set the proper boundaries there. Now, you put another process on the same machine, and if this other process belongs to a hostile tenant or another tenant, then you need to make sure that you have the proper isolation in place, and you will have to work at multiple boundaries there. And they could be incremental, and each one would be just another layer in the defense that you're putting there. So a good place to do the process isolation is to use containers. And this comes for us for free with KubeRay and Kubernetes and the way we're deploying today Ray on Kubernetes. You would have the process. You could limit the process privileges with SecCom, SE Linux, AppArmor. There's a bunch of tools that will help you there. You can do the limiting of computing resources with C groups. You can also limit the visibility by using Linux namespaces. So all of that, you don't need to really worry about it because today when you're using KubeRay, KubeRay uses the pod template in Kubernetes, and that by default allows you to leverage all those constructs. You can see here, I'm just showing a snippet of how you're specifying C groups. You don't know you're specifying C groups, but you are implicitly there. So First level, we're using containers. That we're off to a good start. But the thing is, we're not using individual containers. If you think about how you create a cluster with KubeRay, as a tenant, you're really creating a cluster using either kubectl or Helm. And either way, you're interacting with the Kubernetes control plane. You're not interacting with KubeRay directly. So now you have multiple tenants interacting with the same control plane. You have a shared operator, which is KubeRay, that's talking to the same control plane and creating clusters. So if you think about it if you put the hat of a security expert, now you have to worry about the shared control plane, the shared KubeRay, and those pods that could belong to different tenants that are running on the same machines. And this is what we're going to tackle today. So we defined 3 different levels. We're going to go through each level. We're going to start with securing our namespaces. And a namespace is just a construct, a boundary in Kubernetes that comes out of the box. It's a built-in construct in Kubernetes. And what we're trying to protect against here is basically we're trying to protect pods or workloads from each other. We're trying to protect the worker node or the operating system from the workloads themselves. We're trying to protect our control plane from the workloads and to limit the communication between different workloads. One aspect here is that we're not protecting the workload from us. So as a cloud provider, for example, we're not protecting the workload from the cloud itself. And this would bring us into confidential computing, but this is outside the scope of this talk. So we assume that you trust the platform. You're just securing the multi-tenancy of the workloads in this talk. So the first level, as I mentioned, we just go into the Kubernetes namespace, and we do a policy-based namespace creation. So by default, you make sure that your namespaces are secure. You can inject a bunch of policies, built-in policies in Kubernetes today in those namespaces. You secure that namespace, and then anything else that's running within that namespace is going to be subject or governed by those policies. So if you put KubeRay in that namespace, and it's creating other pods, it is governed by those policies. Now, a good way to do that is to use a policy engine. Now, Kyverno is a good open source project for that. You can define the policy. Every time you create a namespace, it automatically injects those constructs into the namespace. Gatekeeper is another one. All you need to do is have a good story of tenant onboarding. What does it mean to onboard a new tenant? And where do you place a new tenant? You can start by choosing that the namespace is a good boundary between tenants, and you can start by securing the namespace. So this is level 1 isolation. Make sure you inject policies into the namespace and use a policy engine for that. The second level is to isolate the Kubernetes control plane. What we discussed so far, we could have multiple tenants interacting with a control plane to create Ray clusters. However, you could easily envision another scenario where you want to make sure that the KubeRay itself is not shared. And you create a different KubeRay per tenant. You still have the control plane that's shared among the different tenants, but at least now you have different KubeRay per tenant. And finally, you can think of a more stringent requirement where for each tenant, you give them their own version of a control plane, their own configuration and tokens to connect and authenticate with that control plane, and their own KubeRay implementation. And it's simpler than it seems, actually. There are already open source projects that can help with that. So one of those projects would be vCluster. So with vCluster, what you can do is every time you onboard a new tenant, you have already secured the namespaces with Kyverno. Instead of having KubeRay talk to the Kubernetes API server, what vCluster can do is simply inject a new pod inside your namespace, and that becomes your vCluster. And as a tenant, you can simply now interact with that control plane to create other pods, and you will get your own kubeconfig for that particular instance of a control plane, and you will never be interacting with the host control plane here. You will always be interacting with a bounded control plane that's inside a bounded namespace that's creating pods. Even KubeRay, if you put an instance per namespace, it will not be interacting with the Kubernetes control plane. And if we go through a quick demo here, I just have a video demo. It's a scripted environment. All I'm doing here is I'm going to onboard the tenant. I'm going to call the tenant Ray. Automatically, I get a namespace created called tenant Ray. You can see it on the right-hand side. Soon enough, it's going to appear. And inside that namespace, there's going to be already a policy. You can see I already have a quota in that namespace. I already have the policies in place. What happened is Kyverno woke up, injected those policies in the namespace. vCluster is now injecting a pod that acts as a Kubernetes control plane in that namespace. And we can see that reflected into all those objects and pods created in that namespace. Although all I did is just add a new tenant. So this summarizes the first two aspects. Have a policy-governed namespaces and give each tenant their own version of the Kubernetes control plane. Now going to the more stringent requirement of isolating the pods themselves from each other, here we have to think about what type of isolation we want. Everything we talked about so far has been, although we're using containers, it's called process-level isolation. They're all still sharing the same operating system kernel. Even if we have multiple containers here, they all share the same kernel, and they would still be deployed on the same VM. Now, there's no chief security officer that's ever going to approve this solution for hostile multi-tenancy. It's simply not a strong enough boundary between different tenants. And this is where you go to more stringent requirements. And with those requirements, you want to go into full isolation, having virtual machine level isolation or hypervisor level isolation instead of a process level isolation. There are multiple solutions for that, starting with Kata containers, which is a good place to start, although it does make some assumptions about the infrastructure, or you can go all the way into fully fledged VMs for isolating your pods. And today I'm going to talk about an open source project that will help you do that. And it's Virtual Kubelet. Virtual Kubelet is simply a kubelet implementation that masquerades itself as another node to the Kubernetes control plane. But in fact, it's not. Under the hood, it's really two interfaces. One interface making the control plane thinks it's an actual node. And the other interface is one that can talk to any cloud provider and provision those containers for you under the hood, so that you wouldn't even know that you're working with a non-Kubernetes pods there. So if we now want to piece the entire solution together, we already established that we can place each tenant in their own namespace. We injected the policies. We have KubeRay per namespace. The KubeRay is talking to the virtual control plane. And what we can do now is add a different virtual node per namespace. And that way, even the API server here would talk and schedule things on the virtual node itself. In our demo today, what we used Azure container instances. Every cloud provider have their own implementation. But what happens here is that when you create a pod within this namespace on this virtual node, which is an implementation of the virtual kubelet, the call goes to a different Azure control plane called Azure Container Instances. It creates for you a virtual machine. Inside the virtual machine, it will create a construct called container group. And inside the container group, you will have your pod. Now, your pod can talk to the control plane. That's a virtual instance just for you. And then it can go ahead and create other pods. All of this is going to happen under the hood. It would be in a seamless environment where you wouldn't even see it happening. So we might try to do here a live demo. So right now, what I'm showing is simply that I have a Kubernetes cluster. I have a virtual node already installed. And if I just now I can create a pod that's supposed to go on that virtual node. I can see that the pod is in a creating state. And now if I go to our Azure portal and I do a refresh, let me see. Now I see I have the pod that's creating now. If I go wide, I can see that it's created on a virtual node. Again, if I go to my portal and I refresh, I see that I do have a container group, and this container group will be running in its own VM, and this is the pause on VN2 container I created. But the interesting part, if I go to my cluster and I refresh, I see it running just as any other pod in Kubernetes, so I wouldn't even know that this is not a Kubernetes pod, it's actually running somewhere else. So in order to summarize, what we showed today is that Ray and Kubernetes are really a great fit. Regardless where you want to branch out of it, you will find good solutions, good support. So when you're thinking about security and enhancing your security because you're running on Kubernetes, every tool we talked about today is an open source project. It's working seamlessly with Kubernetes. It can help you with multi-tenancy. And we demonstrated how you can have differentiated secure environment depending whether you're working with friendly multi-tenants or hostile multi-tenants. Acknowledgement to the Ray team and Anyscale and everyone that contributes to this. And if you have any questions, I'm going to be around, so feel free to come talk to me. And thank you. Thanks, everyone.